All right, guys, so we are looking at learning objective 14, which is the last learning objective of this particular, I think this is actually learning objective 11 on your study guide. So you might need to reorganize these numbers a little bit, but that's okay. We'll talk about it in class. Anyway, it's the last learning objective for unit 4, which is to calculate the percent yield of a reaction. Okay. So in order to calculate the percent yield, you must know two things. You need to know the actual yield for the reaction and the theoretical yield. Well, we should know what a theoretical yield is, but let's go back over that, right? So the theoretical yield, the amount that is calculated from either a mass to mass problem or a limiting reactant problem. So we've seen a mass-to-mass problem, we've seen a limiting reactant problem. Both of those can give you theoretical yields. So that is where you get that from, okay? So the actual yield is always given to you. So it will always be given, okay? So it's always given in the problem. Or is the, so like what the actual yield is the amount of product that is actually formed in the reaction. So it's the amount of product that is actually formed in the reaction. Okay, so the formula is actually on the back of your periodic table. So if you go to your reference sheet, on the back of your reference sheet, you will have percent yield. It is percent y. It's actually right here. So percent y is equal to actual over theoretical times 100. Okay, so it is the actual yield over the theoretical yield times 100. Theoretical yield is calculated and actual yield is given to you in the problem, okay? So let's talk about this percent yield. So percent yield, what percent yield tells you is it tells you the percentage of the product that formed. You can say that this is the product that is formed, or you can say it's isolated. Because sometimes in the isolation process, we lose some of our product. So when we go to, separate the mixture, sometimes we lose some of our product. Because at the end of a reaction, what we have is a mixture, right? We have a mixture of all of this stuff in there, and we've got to take that stuff and kind of clean it out and isolate what product we want and that type of thing. So a good yield, so if we want to know what a good yield is high. So it's a high yield. So you can say, above a 50%. Some yields are even lower than 50%. Sometimes a good yield's 30%. It depends on the reaction, right? So it's a high yield as long as it's not above 100%. So 100% yield means that I've got something extra that's still in my mixture. So I still have like this mixture. So I've got some sort of contaminant that is in my pure substance. Okay, so as long as it's not above 100%, we're good. A bad yield is not as high. So we're thinking like less than like 20 to 30%. So less than 30%. A lot of times what a chemical engineer will do is look at the yields. If the yield isn't high enough, then they don't think it's a viable reaction. And they look for ways in which to increase the yield or the amount of the product that they can get out of a reaction. Big stuff, like big chemistry stuff, right? So this also indicates the amount of the reactants that you had in the reaction. So sometimes we can go back from the percent yield. So we can find out how much of a reactant that we started with, right? Or whatnot. All right, so let's look at an example here. And we're using the same example from before. So like we got that that one big limiting reactant problem that we did. Okay, so if from the limiting reactant problem above, so to kind of refresh your memory on this, we ended up with 5.5 grams of aluminum that was excess, that was left over. And then we had 0.274 grams of hydrogen, and we had 12.1 grams of aluminum chloride that should be there. That these guys are my theoretical yields, right? So the 0.274 and the 12.1 are my theoretical yields because they go with the products. Okay. So then looking at this problem here, if you only obtained 0.167 grams of hydrogen in the reaction, what was your percent yield? Well, I know from the above, right, that my theoretical yield were 0.274 grams of hydrogen, and I got 12.1 grams of aluminum chloride. Now, I don't really need this, but I just want you to understand, like, if I get to a mass of a product, that is my theoretical yield of that product. Okay, so all I'm doing is taking my actual yield. So this is my actual yield of hydrogen. So I'm looking at hydrogen. And then this is my theoretical. So then 0.167 grams of H2 over 0.274 grams of H2. Notice I'm canceling that out, times 100%. We will get a value here. So then 0.167 divided by 0.274 times 100 gives me 60.9%. So 61%. You can write it as 61% of H2, which is a pretty good yield, right? So like it's above 50%. It's a good yield. And that is the final learning objective, which is to calculate the percent yield of a reaction. So last learning objective for Unit 4. Woohoo! We're done. All right, calculate the percent yield of a reaction.